Today we are going to see the Leetcode bi-weekly contest 80 problem D. This one, last one. So count subarrays with a score less than k. So the question said like the score of the array is defined as the sum of the that subarray into the product of its length, like 1, 2, 3, 4, 5, and into the 5 length. So this is uh, given the positive integers array and the integer k, return the number of the subarrays that are strictly less than k. So let's see the constant. So constant is like 10 to the power 5, and element it goes up to 10 to the power 5 and 10 to the power 15. This is the long. So let's see. So the brute force solution is like create all the subarrays and check for each subarray that will go up to like time complexity n cube. So let's say suppose this is some elements. So we go for this, and this. So after this 5 server is created, then for this. So like we got the n square time complexity to iterating in this array. So once again, so iterating in this array and n into n for checking like for the sum. So this is approximately n cube. So if we use the like prefix sum only, so this time complexity get reduced, so it still goes to n square if we use the prefix sum for the prediction of the sum of this, and the length is like common. So again we got the, but our constant is like 10 to the power 5. It should accept the solution like O of n or O of log of n. So let's see the what is happening over here. So like the value of this the value is should less than k. So let's see this example 21435. So 21435. So let's check with the 2. uh, 2 into 1 is equals to 2, and the k is equals to 10, right? One second, the k is equals to 10. If we get like 2 plus 1 like this subarray, so what is my answer? 3 into 2, that is 6. So it is valid, it is valid. So let's check with one second, this subarray, 4 5 6 7 into 3, that is 21, which exceeds, which we don't take. If we don't get this, then uh, checking this is like waste of time, like waste of time only. So we can check, we can directly say that if we find the this value, like this is true, this is true, false, false, and false. So as you can see, this is forming a monotonic function. One second, let me correct. uh, is equals to 10. So for this I is equals to 0, this is like giving me the monotonic function true true and false false false. So we know that like how many subarrays I can create. I can create this and this, so I can create 2 subarrays from I is equals to 0. So let's see for I is equals to 1. So let me of this. For I is equals to 1, 1 into 1, that is the answer is 1. Yeah, it is right. I can take this. uh, from 1 is to 4, that is 5 into 2, that is 10. It is giving me the 10 but strictly less. So if it is not giving, like it only get like only one answer to me, like from the 4, 4 cross 1 is equals to 4, which is less than, okay. But if we take this subarray, 4 plus 3 is 7, 7 into 2, that is 14, it exceeds. So we can only take one. Like for the 3, we will check for I is equals like for 0 1 2 3 and 4. For the index 3, I will check for 3 into 1, that is like I have taken only the 3, so 3, which is giving me right. But if I take like 5 as well in this array, so it is giving me 3, 8 into 2, that is 16, which exists. I can only take only one. I can move my pointer to this. So if we take the 5 into 1, that is the 5 which is less than. So answer plus 1. So 2, 3, 4, 5, 6. So as you can see, our answer is 6 for this. You can go and uh, dry run for this case. It is working. So uh, let me clear this actually, or how to create a new page. Okay. So what we are going to fix is like we are going to fix some ith pointer over here, and we will check in the rest subarray that it is uh, like at what we are going to search at what index it is giving me the true value, last index, true, and it is giving me the false. So my graph is look like this actually. True means this and false is like this. I need to find this pivot point. So if I find this pivot point, I get to know like from this array it is giving me how many subarrays from suppose this is idx, sorry, this point is idx. So my how many subarrays I will create? I will create like idx minus I plus 1. This many subarrays I can create, and I am going to plus take it for every ith position. So like let me show you the code. So I have take the prefix sum. So prefix sum is main, like for to get the sum the whole array in O of M1 complexity. So I have calculate this prefix sum actually over here. Prefix sum. After calculating the prefix sum and check for like the data type like long or integer count, like for every I am calculating index like idx, like this using the binary search. Let me give the like a letter part. If idx is minus 1, like if I don't find any kind of the index, like this is the possible, right? I am not going to find any of these index. So in that case I'm not going to add anything on my count variable, like the out answer variable. So I have explained this like how I have calculated. This is like uh, is equals to how many sub arrays from I satisfy that given condition, that is less than equal condition, that is like uh, less than k, this value strictly less than k. So this is the how many subarrays. So let's check with the binary index, like binary search, like it is giving me the index. So my low pointer will start will point at like my this index, that is the ith index I am pointing to. It will take the parameter I, n, like how many elements, prefix sum to get the sum, and the k. And my highest pointer is like n minus 1, like this is the last pointer I have to put. And this is the answer that like for the mid, like idx, it is actually the idx only answer is equals to. So if we are going to search, like you should know the like how the binary search works for the, like this is the proper concept of the uh, binary search on answer. If you don't know this concept, then you can go to the Unacademy. There is Utkarsh Gupta class over here. So I'm calculating the mid, and like and this is the count, like how many times I have to product, like I have to product the length of this array, right? I have taken the 5 elements. So how will I calculate the mid minus I plus 1? This is the count. C is like how many elements I have taken, like 5 or 4, and then calculating the prefix of mid. If the prefix of the mid, that is the sum of all over the subarrays. If my I lies over here and my mid going to lie over here, then I have to check for this window. This is the window, right? I have to check. Then what I am going to do, prefix of mid, this is the prefix of mid, and the prefix of I minus 1. I will calculate, I will going to minus this part, so it will give me this part. But what if I is equals to 0? Then it only goes to the prefix of mid. You should check this condition as well. If it is I is equals to 0, then I have to only calculate prefix of mid into the C. This is the value. Or else if I is not equals to 0, then I have to check prefix of mid minus prefix of I minus 1 into the count how many elements are present. If this value is less than k, like okay, I have got a true value, so I have got a true value over here, true. So this is my one of the possible answers. Maybe I got like a true over here, true over here. I have to check for the last of true. Suppose it is giving me like this, I have to check for this. Then my low pointer will point to this. Low is equals to mid plus 1. Low is equals to mid plus 1, or else like if this value is greater than equal to k, then my high pointer will like if my suppose this is giving me true, this is giving me true, this is false, this is false, this is false. My suppose my mid is pointing to the false, then my answer is going to lie from here. I have to find this point. Then I will lower the higher position, like high is equals to mid minus 1. If I have not find any of the I have not found any of the things, like answer is minus 1, then if it is written minus 1, or else written that answer written like index of the true value, the last value. So when it going to give me the minus 1, that is the good question. When my suppose when my array is like 8 9 11 2, suppose my uh, yeah, my eye is pointing to this. So and my k is equals to some suppose less than 11, suppose like 1 to 10. It is not giving me the output actually, so it is written minus 1, so we are not going to take anything. That is why, or else you can also write else count plus equals to 0. If we run this code, it is giving me, if I submit this code, it got accepted. So let me show you why it is not passing in my contest. Because I have done like a very stupid mistake of not passing the prefix sum as the reference. That is why it is giving me like the memory limit exceed in my contest. First for wrong answer, then it got accepted actually. So thank you, hope you like it.